Okay, guys. All right. So I didn't like, I didn't have the printouts for you, and then you had to take it on your own paper, and then I was going between two printouts. I didn't like it, so I'm like, yesterday or the day before, I was like, I gotta do something. I gotta do my own notes. And so I put what I needed in this packet right here. Here's the thing, is I'm still not quite sure. Pick up one of each of those. Which one comes from the actual homework 19, homework 20? I think this is where, I think I got it under control now. But it doesn't matter anyway, because like homework 19, I don't think it's due until, is it Sunday? Okay. So I think we're done with 19 and we're starting into 20. We've done some 20 and 20. I think we'll be ahead, so you're gonna be fine. Okay. All right, grab one each of those. All right, and this is what we were doing when we left on Wednesday. So the other thing that I handed out, or it's over there, is this, okay? This is the review for the final. The final has 25 problems on it, and they are multiple choice, okay? But don't think because they're multiple choice that you're going to go, multiple choice easy. Okay. The thing about multiple choice answers are there's always one or the correct answer. We know what mistakes you'll make, so we put that answer in there. Okay. There'll be one that's totally off. And there's probably another one that you made a different mistake. So you got one totally off answer, you got one that's the correct answer, and then you got two that we know the common mistakes people will make. Now, I didn't make the final, so it's not on me, but that's how you're supposed to make multiple choice finals. So anyway, okay. We are still going on with logarithms. We're going to learn about expanding and condensing. Honestly, now I have to say, you guys, and it's probably because of Alex versus Pearson, you guys are staying up with your homework. People who are using Pearson are not. So that kind of leads me to tell you that I like Alex better. Okay? I know you probably don't, because you have due dates and you have, it is constant, but guess what? It keeps you accountable for doing the material. You know as well as I, well, I don't know. If you were like me, as a student, if my instructor, they didn't count homework, they didn't collect homework, guess what? I ain't doing it. Okay? I wasn't. I'm just gonna be honest. And then when test came, and then I'm like, oh crap. I'm just gonna write down something and hope for the best. Hope for that curve. So, that's why I do, I remember when I started teaching here, I'm like, you mean to tell me college students, I gotta collect homework and do things like this? And I was like, oh, I never had that in college. Now, again, it really kind of stinks as far as you having to be accountable, but yet the good stuff is that you know the material, okay? You're not gonna fail every single test. You might fail one, okay, because you slacked off or whatever. So, the part that we're getting ready to get into is, we learn skills first, then we learn how to solve, and then we learn application problems, okay? Application problems are why you learn math. You use math every single day of your life and you don't even know you're using it. All right. Again, I've used it just like figuring out the time so you can get here on time. Those are all problem solving things. So who knows what you're going to do when you get out? I don't know what math you're going to use and what math you're not going to use. I don't know. It depends on your job. Okay. So the expanding and condensing of logs is going to help us solve the logarithm equations and exponential equations. Okay. So this is why we're going to learn these rules. All right. So here's all our basic properties. We took that on your own notes the other day. Okay. This you've already taken. These two, I said you could probably know this you could do it without knowing those because using the circle of logs. But these two are what I call the cancellation properties, these last two. So let's take a look at this. This one here has a rule, okay? It has one. It is this one right here, okay? It has a property where, see how the bases are the same? They're going to cancel each other out to give you one. Now, there's a couple ways. I also could use this one right here. But if I didn't even know any of that up there and that somebody gave me this problem, this is what I would do. I'd say 2 to the what power gives me 2. And what does that question mark have to be? Just 1, right? So I was able to do it without knowing that property, right? Now, but I want to show you something else. This has a power of 2. I'm sorry, power of 1. So does this one. Okay, it's the same thing. Well, what this says is if the bases are the same, the exponents have to be the same, right? If the bases are the same, the exponents have to be the same. So that's why that question mark's 1. This one right here, however, if I was going to use a property up here, this has an exponent of 1. What happens is that's this formula right here. When the bases are the same, they can't, this is why I call it cancellation property. I have log base 2 and I have a base 2. These two cancel each other out to just give me that exponent. That's what this one says right here. Okay. This one right here, this has a power of 1. What happens to the base 19s? What happens to them? They cancel each other out, right? Okay, so this cancels with this. So we're just left with 1. Now, you could use the circle of logs if you wanted to. You don't have to. But now that we know the shortcuts, now that we know the shortcuts, we're going to use the properties. Okay, what does this have a base of? E. Yes.
Yeah, I was just going to say that.
Do what?
I was just going to say.
Good, yes. Okay, so this has an E. What does this have an exponent of right here? A 1. So again, these cancel out, and I'm just left with 1. Now this one right here is different, okay? The bases are not the same. But again, if it were me, I'd be doing the circle of logs on this particular problem. Because until I get used to knowing and used to that logarithms are exponents. That's what you're trying to do. Logarithms are exponents. So you're saying 273 to what power? Oops. You can see that. To what power gives us 1? And what power is that going to be? 0. I don't know why I'm doing my 1s like that today. I have no idea. Okay. Let's go over here. Grab one of each of those. One is a review for the final, just so you guys have it. All right. And the other one is what we're working on now. Zero. Yeah. All right. Same thing here. 1/8 to what power is going to give us 1? 0. Anything to the 0 power is 1. Again, you do the circle of logs. If you need to, you don't have to, but that is always a possibility. I'm going to go back to doing my 1s that way. And so you get 0. The only way you can get 1 with an exponent is having it as a 0. What happens to our bases right here? What happens here? They cancel. So what's our answer? 10. And guys, if I asked you to show your work on this, That's all you have to do. That's showing my work, okay? What's my answer here? -12. Again, this has a base E, so these cancel. Now, this here is this one. It is this one. It's the exact same thing. They have the same bases, okay? So this 8 and this log base 8 cancel each other out, so you're just left with 5. And then what is my answer right here? 14, good. All right. Okay. Now, product, quotient, and power properties of logarithms. Okay, I call these the laws of logarithms. So depending on your book, the book calls them the laws of logarithms. They're the rules, basically. Okay, so first off, we've got product, that just means multiplication. We got quotient, which means division, and we've got power property, that's exponents. Okay. So if you see some log with some base, and you have x times y, to expand it, you're going to say log base b, or whatever that base is. That b just stands for a number, okay, of x, plus log base b of y. To expand division, you subtract them. The exponent one, what happens is you have an exponent, you take it to the front. And that's all there is to it. It's not, this should not be difficult for you, okay? Now, if you don't know which one goes with which, only my suggestion to you, meaning multiplication and addition go together, division and subtraction. Think about it this way. What do you learn first? To add or subtract first? You add, okay? Well, what do you learn first? Multiplication or division? Multiplication. So the two things that you learn first go together, and the two things that you learn second go together. Okay, so adding goes with multiplying, subtracting goes with dividing. I don't have anything for the power rule. Okay, so let's take a look at this problem right here. To expand it, this is multiplication inside here. So what you're going to do is you're going to say log base 2 of 8 plus log base 2 of x plus log base 2 of y. And I don't know what, I think your directions will say expand. Now, if this didn't, okay, notice some things, okay? See how this was a log base 2 right here? That means all of them have to be log base 2. You can't change that to just log, because then you're talking base 10 and that totally changes this problem, okay? So you can't do that. The other thing is when you have letters and numbers like these two, you're fine. But here, you always have to check to see if you can simplify. Always. If this had been a 7, you'd been done. Okay, if it had been a 15, you would be done. But 2 to the what power gives you 8? 3. 3. So that will simplify, remember, because logarithms are exponents. That is 3 plus log base 2 of x plus log base 2 of y. Okay? That's the only thing you got to be careful about, because that took me, it didn't take me long. I just always skipped it. And I'm like, oh, got to get used to that. I'm used to it now, but I wasn't when I was starting this.
The final answer.
That's the final answer, yes. Okay. So now, this is multiplication here. By the way, you see this a plus b? We do not have a rule for addition. Our rules are these, okay? We only have rules for product, quotient, and powers, exponents. So right here, the only thing that we have is multiplication. This says 3 times the quantity of a plus b. So what goes with multiplication? Addition. So we're going to say the natural log of 3, and I don't care if you put those in parentheses or not, it doesn't really matter, plus, because of this multiplication here, the natural log of a plus b. Yeah. Okay, you do not split up that a plus b because we don't have a rule for it. Okay, right here. We have division. What goes with division? Subtraction. So you're just going to say log base 7 of z minus the log base 7 of 49. I'm going to tell you all something in just a minute. Okay, this one's fine. Is this one fine or can it be simplified? What to? To 2, right? Not to 7. It's not 7 times 7. I mean, it's 7 to the second power, right? Takes a little while getting used to. Not hard. You just got to think about it. Okay. Questions on that? Okay. No, I was laughing. A little thing came through that said something about Tony. And I'm such a bad wife. And I'm not. I'm really not. We're going to see Connor tonight. So I cook him chicken to take it to him so he can have it and he can just heat it up. And I make these protein things for him, bars for him. So this morning, I'm up at 7 o'clock. I'm cooking him chicken. I'm making his protein bars. And then I get in the shower. So I get out of the shower. Tony's already taking a shower. He's done. He's out the door and I'm still working, cleaning up the kitchen and crap. And I'm in the bathroom and I'm like, he's just wandering around the house. He's waiting for me to offer him to cook him breakfast. Because I take these vitamins in the morning. If I don't eat and then I take them, I don't feel well. So and he's been home. He used to get up and go before I was even out of bed. Now he's home because it's cold out. You know, they don't start as early in construction. And I'm like, he's out there. He is, because I heard him talking to his dad. I saw him look over and he has his bills on the kitchen table. So I was talking to him on the way and I was like, he's like, did you see that? And I said, no, I was probably eating my breakfast. He's like, oh, didn't offer me it this morning. I said, no. Because I was sitting there, I said, you know what? I said, I knew you were waiting for me to cook you breakfast and you were not, but it takes more time. I don't have that kind of time. I guess I could if I got up early enough, but I don't care enough. So, but I'm like, it would have been nice if he'd have said, hey, Kim's been doing this. I'll make her breakfast. Yeah, never. Anyway. Just to give you a heads up, guys. Yeah, we do things like that. All right. he said to me, he said, you just watch. You just see if I'll just stop washing your car. And what was it? Picking up something. I don't know. I was like, you just stop doing both of those things. And let's just see if the world continues. Because it will. Because I'll just take my car through the car wash. I don't really care. I mean, it's nice. He does a good job. But I don't really care about that. I can just go take it through the car wash. And if he does take trash to the dump, but I'll just pay somebody to come and pick it up. You know, there's trash people, the trucks come through our subdivision. Anyway, okay. Back on, I don't know why we're behind. I have no idea. Okay, the problem with logarithms is you do not want any radicals. Okay, you don't want radicals, which we have here. But we have learned how to write this as a fractional exponent. We just took a test on that, right? So how would let's rewrite this as x to what power? Anybody remember? How do we write this as a power? What is it? Close. It's 2/3. It would be 1/3 if this 2 hadn't have been here, okay? So it is, yes, remember the root is always a denominator, so it's to the 2/3, okay? Now we're going to use our power rule. We have an exponent. The only thing you have to do is take that exponent to the front. So we have 2/3 times log of x. The only other way, this is how I would write it. The only other way it could be written is 2 log of x all over 3. Okay, I don't do it that way though. I just do it this way. Just know that they're the same. Okay. All right. Right here. What are we going to do with the 5? Just going to move it to the front. Okay. You're going to take that 5. Good. You're going to move that to the front and you get 5 natural log of e. Not hard, is it? Okay. No. You could write this. Question was, do you have to have the e in parentheses? You could write it like this. Okay, it's the same thing. Yes.
Why would we not simplify?
I guess we could. And good catch, because I did this the other day in one of my classes and I didn't catch it in one class, but I caught it in the other class. You would, because otherwise Alex gonna count this wrong, right? This has a base e. So what does this cancel to? Just 5, because see this? Good catch. Yeah, see, I didn't even catch it. Natural log of e and e, those cancel each other out. So you really have 5 times 1. 5 times 1 just gives us 5. So good. Again, this here, these cancel each other out, just give you 1, and 5 times 1 gives you 5. Okay. I didn't write that part out. Okay. Right here. First thing you want to do is expand it. You want to do the exponents at the last. Okay. So here's what we're going to do. We're going to do the natural log of x squared. What are we going to do? Add or subtract? Add. Plus the natural log of y. Now what do we want to do with the 2? Take it to the front. So you have 2 times the natural log of x plus the natural log of y. Okay. The only difference, what we've done so far is now they're just getting longer. Okay, but I'm going to show you a shortcut. I'm going to show, well, this one, there's no shortcut. This one, we're going to do it the long way, but then I'm going to show you the shortcut, and then we'll use the shortcut from here on out. Okay. So right here, we're going to have a log base 3. You got to have that little 3. This is multiplication at top. So what are we going to put between it? Plus. Okay, we're going to add log base 3 of 5. Will that simplify it all? Is there 3 to any power? No. So we're good with that. We don't have to worry about it. Plus log base 3 of z. And now we have division, right? So what do we put? Subtraction. Minus log base 3 of w. Okay? So now, we're going to get to this one. And we have 2 things that we're multiplying on the top and 2 on the bottom. And then we're dividing it, right? So it's similar to this. If you could plug it into your calculator, we would have to do this in our calculator over this in our calculator to get it to simplify. Yes.
Why can't there be a square law?
Just the laws, it's the rules of the logarithms. You'll see it when we start solving what happens when we do that. But it won't work if you leave it where it's at. I don't know where it came from because I don't know, I don't work with logarithms that much. I just know it's kind of like, I actually now, growing up, I never knew why anything to the 0 power gave me 1. Okay, the teacher said it. I'm like, okay, that's it. Now I know there's a couple different ways I can explain it, but I don't know why that is. Okay, so on the top, we're going to put addition, right? And then we're going to have subtraction, but we also have addition on the bottom. So I'm going to do this a certain way, but then I'm going to show you the shortcut. So on the top, I'm going to put it in brackets. I'm going to say log base 7 of A plus log base 7 of C. That's the top, right? And the reason I'm doing this is because I have more than one thing at the bottom. I got the top. Now, what am I going to do with what is this? This is division. So what is it? Subtraction. So now I'm going to put the whole bottom in parentheses or brackets. I'm going to say log base 7 of 5. Will that simplify it all? No. And then what do I have between here? Plus, because it's multiplication, log base 7 of D. Okay? All right. But what happens to everything after the subtraction sign? What happens here? This becomes what? Negative. This becomes negative. Okay? Everything behind that subtraction changes to a negative. So really what I'm going to have is log base 7 of A plus log base 7 of C. And then I'm going to have minus log base 7 of 5 and minus log base 7 of D. That's my final answer because the only thing I would tell you is check to make sure this doesn't simplify, but it won't. Okay. All right. The shortcut to this is, let's see, if it's in the top, it's addition. If it's in if it's in the bottom, it becomes subtraction. All right. See how both of these became subtraction? Because we're dividing both of them. So that's what we're going to use from here on out because it's going to make things faster. All right. You can do it if you want to, but the reason it becomes that is because you're going to distribute this negative. That's how it becomes that. Or that subtraction sign. All right, right here. We're going to have log base 8 of 64 plus log base 8 of x squared what is the 3 going to be? Positive or negative? Negative. So I'm going to have minus log base 8 of 3 minus log base 8 of z minus, I think this will be the last one because I think you guys get the gist of it, log base 8 of w to the 3rd power. 1, 2, 3, 4, 5. Okay, now on this, we still aren't finished with because of the exponents alone, right? But you always have to double check on these two to make sure they don't simplify. Is there anything 8 to any power to give me 64? 2. Good. All right, so this simplifies to 2. What's going to happen to this exponent? It's going to go to the front. So I have plus 2 log base 8 of x minus log base 8 of 3 by the way. Is there anything that I can raise 8 to get 3? No, so that's good. And then minus log base 8 z. And then this one here, what do I do with the 3? Move it to the front. So I have 3 log base 8 of w. All right. By the way, I'm not gonna do. I'll finish this one in a text. Yeah. To start this one, okay. You don't want to have that radical. Okay. That radical, I can take that out by saying this whole thing, because it's underneath that square root, it is 4 times x minus 1 over w to the 3rd power. That whole thing, I can replace that with what? Does anybody know? Square root is the same thing as what's the what power? Not to the 2nd, but the 1/2. Okay. Anything by the square root is the same as 1/2 when you take square root. Okay. So look at this here. This is the same thing as this. You know why? Remember we just did one right here. It was 2 over 3, right? 2 over 3. Because the root is always your denominator. Well, square means 2. We don't write that. This is 1 right here. It's 9 to the 1/2. I am going to tell you, you do need to know that taking the square root of something is the same thing as raising it to the 1/2. We use that quite often in other classes. Okay. So if you saw this answer right here, this problem, you're going to say 3. Okay. If you said 16 to the 1/2, what's my answer? 4, because it's the square root of 16. It's the same thing. Okay. Now we have to do some manipulating on that problem, but I want to go on to solving, and I'll finish this one up in the text. Okay. This is why I didn't want you to get rid of the other paper. Okay, now let me see where we're at in our notes. All right. Okay, when I started with 19, okay, I think that was fine. But then I got over to our homework. I'm gonna do this because this is my note. Homework 20. And I was like, we didn't go over expanding and condensing, so we couldn't do these problems. So that's why I have to go and do. So if you want your notes like how they should be, what I would do is, I don't know, did we do any on these here? I would just rip that off and I just staple what we just finished to here. Okay. All right, because we didn't do any of 19 on these pages. Did we do any of these? We did it. Okay. Okay, we did do those. Okay. Okay. All right. So with 19, take this paper off, put what we just finished in here. Basically, you're just going to take what we finished and put right after the first page. Okay. Now, if you want, I can. It was not going to work. What the deal is with this semester and the staplers? Our rooms haven't had them. You just have to escape and let them at home because this one's not working. All right. Okay, so basically just take off 19, stick that in there and stick them back together. Okay. All right. Because 20 is in two parts, apparently. Okay, so we are going to go to this right here. Okay. All right, look at the difference in these two equations, all right? This one right here, they're all log base 3. Okay? Over here, this is log base 3, this is log base 3. That one doesn't have it. Okay? These are worked differently. Okay, these are worked differently. And that's what we're going to learn how to do this. Okay, so here's what we're going to do. We're going to look at this one right here. Do what? I do not. I do not. But
I'll just write it on transfer.
yeah, I was gonna say, just write the problems down and transfer it. Okay. Because I think I cleaned out my backpack and I cleaned out stuff I wasn't supposed to clean out. They're always up there until I'm in class. So, okay. So what happens when I tried to get organized. Okay, so we have log base 2 and log base 2. We're good. All right, when that's the case, this is going to imply for these to be equal, this has to equal whatever that is. In order for those two sides to balance, this implies that 5x minus 1 has to equal 2x plus 14. Otherwise, they're not equal. If our bases are the same, everything else has to be the same, okay? If you ever see me do this, that means implies. You don't have to have that, it doesn't matter. So now we solve this equation. We're going to take this 2x to this side. What do we get? Are we going to add or subtract it? Subtract it and we get 3x because I'm not showing this work. If you want to, you can. Then I'm going to take the 1 over to that by adding it. And what do we get on that side? 15. Now, guys, I skipped 2 steps there. If you need to write them in, you write them in. I subtracted 2x and added 1. That's 2 steps I did. Now, what do? Divide by 3 and we get 5. Again, I didn't show that step because that is stuff that we learned the first week of school. Or you didn't learn it, we reviewed it, okay? So it's just solving an equation. Now, let's just see if this works. If I checked it, I'd get log base 2 of 5 times 5 is 25 minus 1, right? That gives me log base 2 of 24 over here, right? On the right-hand side, I'd have log base 2 of 2 times 5, which is 10, plus 14. That gives me log base 2 of 24. See how they're now equal? That's what we're trying to do at this point. Okay. Are our logarithms the same? So what does that tell you this has to happen? This has to be true, right? Now, I am going to tell you, you need to check these. You need to check every single one of these problems. Notice I checked it here. Okay? Here needs to be checked as well, because I'm going to have x minus 7 equals 5 minus x. Okay? How am I going to get this x over here? Add it, right? I'm going to add x to both sides. So when I do that, I get 2x over here. How do I get rid of the 7 and take it over to this side? Add 7, right? But if you need to do this, then do this, okay? I'm just not going to work all that. That gives me 12. So what is my x? 6. Okay, we have to check it. Okay. All right, we're gonna check this, and we're gonna have log of 6 minus 7 equals log of 5 minus 6, right? Now, here's the thing, is over here, you're gonna get log of -1. And you're gonna get log of -1 here, okay? But we can't have that. We can't, there is nothing that I can take, because it's log this, right? This has a base of 10. 10 to what power is going to give me a -1? Nothing. You know why? Some of you are going to go, well, -1. No, that gives me 1/10. We never can end up with a negative number there. We'll never get it. 10 to the first is 10. 10 to the second is 100. 10 to the 0 power gives me a +1. 10 to the -1 gives me 1/10, not -1. So this one would be no solution. And look here, solutions for all log equations must be checked to ensure the solution is in the domain. Okay, well, it's not. So we would just say no solution. I don't know what they're going to ask. If it's going to be no solution, I put doesn't check, and then I put no solution. And sometimes, I don't know about Alex, but it might put a 0 through a slash through it. Have you seen that in Alex yet? You have? You haven't? I mean, I know I've seen it before. I just don't. Some books will use it early, some won't. I can tell you right now, if you use photo math, okay, like me, I want no solution. Alex probably wants no solution, I'm thinking. Photo math uses this. Okay? So little things like that, when, if you were using photo math on a test or something, somehow, okay? And you write that, I'll be like, we never talked about that. We don't do it. So I'm going to erase that now, but I just need you to know that that does mean no solution. See, I don't mind. There's a time and a place to use things like photo math. I don't care if you have the answers on your homework. I want you, I mean, I give you every answer to the review. Why would I do that? So you know where you made your mistake and learn from it. And then you go to my notes and go, oh, well, how'd she get that? And you look at that. If you were using photo math and you were using your homework and you came up, you worked it, you checked it before you plug it into the computer, and you find that it's wrong, then you go to the steps that photo math did. The majority of the time, it's okay. Every once in a while, whoever entered that information in it, because anybody can pretty much enter that information. But sometimes they work in a weird way that I don't even understand. So that's how I caught the one kid cheating one time, because I know he can't do it that way, because I can't do it that way. And I had already had him for a couple tests. So, okay, so that's what you're going to do. You're always going to check, okay? And you got to remember, domains are, and even though this one isn't, this has nothing to be within the domain. Domain with logarithms, they start at 0 and they go to infinity. Okay, 0 to infinity. So right here, we are going to have to use a combination of things before we can do this. We just learned to expand, right? Now we're going to condense. What is subtract? See how they're all log 3? How do you condense a subtraction? Division, right? So we are going to write this way first. We're going to say log base 3 And we can condense this to 3x minus 4 divided by x plus 1 equals log base 3 of 2. Questions on what I did right there? The reason we did division is because it was subtraction. See, if I had expanded this, it would look like this. Now we're going the other direction in order to solve. So now, because they have the same base, we can set our arguments equal to each other. This here is just a solving an equation. I'm going to teach it just like I have always done it. I'm going to multiply both sides by the denominator. That there is going to get rid of our denominator. That is nothing new. And I'm going to have 3x minus 4 equals, I'm going to distribute this 2 to get 2x plus 2. I'm going to take this 2 to the other side by subtracting it. And I get x. I'm going to take the negative 4 to the other side by adding it. And I get 6. You want to check it, okay? You want to make sure that it's okay. I do believe it checks 18. We have log base 3 of 18 minus 4. That gives me 14 minus log base 3 of 6 plus 1 gives us 7 equals log base 3 of 2. Well, if I divided this, right, because this goes with division, right? 14 divided by 7 gives us that 2, so that left equals the right. All right, this one right here. They all are natural logs, all natural logs. So it is, what goes with plus multiplication? So on this side, we have the natural log of x times x plus 3 equals the natural log of 10. So now we have 1 on each side. We can just say x times x plus 3 equals 10. We're going to distribute that x squared, the x, and we get x squared plus 3x equals 10. I'm going to subtract 10. Because we've got it, when you have a quadratic, you got to set it equal to 0. At this point, you can factor or you can use quadratic formula. I'm going to use factoring because it factors. It's going to factor as x plus 5, x minus 2 equals 0. Right here, we get negative 5. Right here, we get 2. But guys, the domain of logarithms, this is our x, right? We get x equals that. Domain is our x. The domain of any logarithm is 0 to infinity. So which one do we have to kick out? That negative 5, because it's not part of the domain. The domain is from 0 to infinity, okay? So, and then you plug it in and check, and it checks. All right. Okay, we will pick back up with this on Monday. If, I don't know, 20 is not due, right?